So I want us to consider this question that we are given, which is question number 6 on our single phase. All right, so this is a single phase AC theory. So we are given that a 2.5 kilowatt single phase capacitive load, it's a single phase, a 2.5 kilowatt. That is, we are given the power in that case. All right, so in this case, guys, I'm just gonna take our information that we are given. That is the power of 2.5 kilowatt capacitive load. It is a capacitive load. So it can be inductive or it can be a capacitive. Is supplied at 240 and frequency of 50 hertz. So we've got the voltage at the input, which is 240 volts, and the frequency of 50 hertz at the supply. The load operates at a power factor of 0.8 leading. Remember, this is a capacitive, so it must be leading. Inductive, it must be lagging. All right, so we have got a power factor of 0.8 leading. Remember, the power factor simply represents the cos of theta. So that was the condition. From 6.1, we are given calculate 6.11, the phase angle of the circuit. The phase angle of the circuit, which is the theta. From the power factor, we can calculate our theta. Remember, we have got a power factor there. So it follows that from the power factor that we are given, we can calculate this theta. Remember, the cosine of theta, which is the power factor, is 0.8. So therefore, theta is going to be the arc cos of 0.8. That is shift cos on your calculator. So that was going to be 36.87 degrees. Okay, so you can actually fix your calculator to 3 decimal places. Then you can round off that. Okay, let me just show you guys what I'm trying to say. That is shift cos 0.8. So it's going to be 36, so if we shift this, if we fix this to 3 decimal places, it's going to be 36, so as you can see, it will be a 0 there, which is just same as 7. Okay, so if you want to place that, it's fine, no problem. So that is our power factor. You have got, the angle that you are given, which is the phase angle from the power factor. All right. 6.12, the current drawn by the load. That is 2 marks, the current. So remember, we have the power and also the voltage. This is a single phase, not a 3-phase, guys. This is a single phase. So on a single phase, we just take our formula to be usual. The power is the voltage times the current times the cos of theta, which is the power factor. So from this, we need the current. So we are going to divide by the voltage times the cos of theta, the voltage, the cos of theta. So this is going to give us the current. So it's simply the power over V cos theta. So this, remember, cos theta is the power factor. Cos theta is the power factor. So you just substitute the 0.8 as it is. The power, that's 2.5 kilowatt. So our current is going to be 2.5 times 10 to the exponent of 3. Okay, so that is over the voltage. Remember, the voltage is 240. So that's 240 times the cos of theta, which is the power factor. Instead of you using this angle that you remember, you calculated the angle from that cos of theta. So it's already there. Cos of theta, that is the 0.8. All right, so that was going to give you the current in this case, all right? So the current was going to be 13,02, 0208 and so on. So that was going to be 021, 3 decimal places. Like I said, you can also fix your calculator to 3 decimal places. So that was going to be current. All right. From this, we need the reactive power. The reactive power. All right. How do you calculate the reactive power? Remember that the reactive power is considered from the sine of theta. So this is 6.13. Q is equal to VI, the sine of theta. All right. When it is on a 3-phase, you're going to use the square root of 3, and there you'll be working with the line voltage, line current. So in this case, guys, it's something that is straightforward. So that is our reactive power. The voltage, remember your voltage, guys, it was 240. You calculated the current right now. That is, you have got 13,021 times the sine of theta. This is not cos theta, it's sine theta. So you must substitute the theta exactly, the one that you calculated, which is 36,87. So this is going to be the sine of 36,87 degrees. So that was going to give us the reactive power, which is 1875,028, which is volt ampere reactive. You can also divide by 1,000. That is going to be 1,875, which is kilovolt ampere reactive. So to convert to this, we're just going to divide by 1,002, the kilo volt reactive. That is the idea there. That is the idea. So you can calculate any question, the impedance of the load, impedance, which is Z. So where can we obtain the impedance? We have got the voltage and we also have the current. So you can take advantage of that, remembering that the impedance can be calculated from the voltage and the current. Remember, this is a single phase, guys. So voltage over current, that's impedance. The voltage, we have it, that is 240 divided to the current that we calculated before, which was 13,021. So that is the impedance, which is 18,432 ohms. So this part, guys, it is a direct part. Remember, it's a single phase. You just consider just like you are in a DC circuit, resistance, it's voltage over current. So this one, it's impedance. It's now a single phase. So you consider alternating, working with impedance, a DC, it will be just resistance. All right, 6.2, then you're asked to draw the phasor diagram to show the voltage, current vectors, as well as the phase angle. So in this vector diagram, we need to see the voltage, the current, and as well as the phase angle that we calculated. Remember, we were given this is a capacitive circuit that is leading. So in this case, we are going to have our current leading the voltage. So that is the current leading the voltage by an angle, theta, which is our theta. Remember when we calculated this theta, it was 36,87 degrees. All right, so that's it, guys. Not much. There's nothing much. You can even write the values. Current, remember you have got these values. Sorry for that. Very sorry for that. You have got these values for current and voltage. So you can also write your values. So that was your typical question. Working with a single phase, 10 marks. Revise as much questions as you can. These questions, they do repeat now and again. So do revise as much questions as you can.